Hello, welcome to Ecp. First thing first, well done for year 11s, and it's time to getting serious, getting started from Ecp. Me and Maddie gonna start with today's lectures and sessions. So from today, I'm actually gonna start very simple one, which is the chain rule, which is we actually learned from the year 11s, and as some people actually mentioned before, was like it's the most important rules we never know, and in the derivative. Okay, so start with remember this one into your buffer reference, which is you're gonna write down this dy dx equal to dy du times du dx. This is a basic knowledge for the notations, Leibniz notation. And we know u equal to gx, y equal to fe, and something like that we are using the discuss sessions. Okay, start with example 1. So differentiate y equal to 4x cubed minus 5x to the power of -2. So once you say this one, it's kind of complicated. You had one whole equation inside the bracket. So how we do this question? So let's start with y equal to 4x cubed minus 5x. If you can, rewrite it about the questions. And then I will say let u equal to 4x cubic minus 5x. And once I'm getting this one, and then we can say du dx equal to 4x cubed, so it's the 4 times 3, x to the power of square, and minus 5. And then your du dx equal to 12x squared minus 5. Perfect. And then circle that one, just in case you forgot it. And then we're doing next one is, because u equal to 4x cubed minus 5x, so we can say y equal to u to the power of -2. So now your dy du equal to -2 to the power of -3u, so which is we know. And then we got a dy du and du dx. So adding all together, dy dx equal to 2, -2u, -3, multiplied by 12x squared minus 5. And then we actually can do is to rewrite as u have x, because dy dx don't have u. So we become dy dx equal to -2, 12x squared minus 5 bracket over 4x cubed minus 5x to the power of cubic. And you can write as a fraction, you can write in the one's whole equations, I don't mind. For my personal opinions, actually, I love to do the fraction in the end of the solutions. So, yeah, let's see. And now we keep going with the CAS calculator. So I will do the CAS calculator during the class as well. So I'm just sharing this page of the picture and about how we're gonna get in our calculus derivative and so on. And I'm actually gonna share this one with you guys in the class. And please make sure going to the classroom and know how to use the CAS calculator, because in year 12, the most important part is using CAS calculator. Yep. Well, I'm gonna keep going with example 2 now. So let's have a look at the questions. Find the gradient of the tangent to the curve with the equation y equal to 16 divided by 3x squared plus 1 at the point is 1, 4. Okay, once you say the gradient of tangent to the curve, you have to find the derivative. Once you need to find a derivative, and how we're going to find it, let's have a look. Y equal to 16 over 3x squared plus 1. So let 3x squared plus 1 equal to u. du dx equal to 3x times 2 equal to 6x. Perfect. And now y equal to 16 over u, or we can say 16 u negative 1. Your dy du negative 16 u to the negative 2. Perfect. Now we have two things. And now we're going to do is find the dy dx equal to negative 16 u to the power negative 2 multiplied by 6x. And that equal to negative 16 times 6x over u squared. Because as I said, dy dx don't have a u, so we have to substitution back become to negative 16 times 6x over 3x squared plus 1 squared. And negative 96x over 3x squared plus 1 squared. Perfect. And then find the gradient because your y equal to 4 when x equal to 1. So now, when x equal to 1, dy dx equal to negative 96 times 1 over 3 times 1 squared plus 1 squared. That equal to negative 96 over 4 squared. That equal to 16. 96 equal to 6. So that is your, negative 6. That is the gradient of tangent to the curve. So you can write the answer is the gradient when at x equal to 1, the gradient is negative 6. Or you can say it's equal to negative 6. Perfect. Well, that's the question about the chain rule. Perfect. And the question, by the way, you have to do is, I really want you guys to do all questions. Stop sharing.